Hello everyone, back tuning into the 13th Winter 2020 update part 1. So here we are, we have done 12 updates so far. This is our 13th and final winter update. It's all come down to this. 3 months worth of winter updates have brought us to this point, which is the 13th and final update. So I shall get on it for you very shortly. It's going to be an epic, of course, with all of the winter updates. They're all epics, but this one in particular is going to be a very epic update, I think. So sit back, relax, get yourself a comfy chair and a cup of tea and some nibbles, because we are going to be here for some time. But once this is done, then that is it for this season of winter updates. I hope you enjoyed this season of winter updates. I think they've been among some of the most extensive and absorbed, sort of winter updates that we have ever done, and I just hope that everybody has enjoyed them. But we have still got the 13th update in 2 parts, so part 2 of this update will be released tomorrow. And as I say, once that's out of the way, then that is it. That really is it, and all that is left is to release the winter forecast on Wednesday. GavsWeatherVids Winter 2020 forecast is going to be released as a premiere on the YouTube channel on Wednesday at 8 o'clock in the evening. I'll be releasing it at 8 o'clock in the evening on Wednesday. So, it'll be premiere, have a full premiere with a countdown and everything. And I'll be in the live chat with all of you. And we will see it as a premiere together. And then it will be released across GavsWeatherVids.com. And I'll probably get onto Winter Updates page with a written summary on Thursday morning, I would have thought. But yeah, winter forecast time on Wednesday. But before that, let's not get ahead of ourselves. We have got this 13th update in 2 parts to do, and I will get on with part 1 very shortly. Just to say that coming up later on today, we're going to have our Christmas update. It's probably going to be around 3 o'clock, I would have thought, this afternoon, sometime around then, sort of mid-afternoon, our latest Christmas update. And then we will have a live stream for you at 6 o'clock. We'll run a live stream from 6 until 7. And it's going to be absolutely great. It'll be absolutely fantastic. And I shall see you all on the live stream. No doubt we'll be talking about this winter update as well as the Christmas update. And I'm sure we'll be looking at winter data from CFSV2 as well. So it's going to be absolutely fantastic. That'll be from 6 until 7 o'clock. Thank you so much to Richard, for the amazing Winter Updates gift. This 13th update will be the last time that you see Winter Updates gifts. You'll be seeing it plenty of times through this video and also part 2. But thank you so much, Richard. Everybody has loved this year's Winter Updates gift. It's definitely been one of the best that you've done. So thank you so much to Richard, my good friend Richard Traut, for the Winter Updates gift. Gotta say thank you to Shryan as well. Thank you so much to Shryan. And I'm also going to say thank you to James as well when we get to sections where they have helped out with this 13th winter update. I will, of course, tell you where they have helped out on the update. Thank you so much to Richard, to James, to Shryan as well. I think that's pretty much everything that I'm going to tell you. So shall we do this then? Shall we start? Shall we begin the 13th Winter 2020 update, the final update? Let's start doing it then. So where we're going to begin is, of course, with the swingometer from our King of Swing, Richard Traut. So the swingometer has been updated up to the end of last week's 12th Winter 2021 update, which, of course, was a QBO special with the anomalies particularly focusing on westerly and west to east QBOs. So shall we do this then? Shall we show you the QBO? Here we go then. 1, 2, 3, 4, 5. This is our swingometer as of the 12th winter update. Here it is. The swingometer is still favouring a colder than average winter from 12 of our updates by 51% to 49%. We have got a ever so slight favourability there to a cold winter. It's barely moved from last week. There has been an ever so just tiny little swing from cold to mild, but just last week it was 52 to 48 to a cold winter. Now it is 51 to 49, but we are still just about favouring a colder than average winter as of the end of the 12th winter update, with just one more winter update to go. So thank you so much to Richard for sending us our swingometer. And you will get to see, by the way, the swingometer at the beginning of the winter forecast. So the swingometer will be updated by Richard to like the end of the 13th winter update, so to the end of winter update essentially, and it'll be the first thing that you see at the beginning of our winter 2020 forecast. You will see the swingometer, and you'll see how these winter updates have favoured overall, you know, the full 13, how they have come out, and whether they're favouring a colder winter, a milder winter, or they don't favour either option, which of course is a possibility. So yeah, that's going to be coming up for you as the first thing that you'll see on winter forecast, which is going to be again released at 8 p.m. On Wednesday, 2nd of December, as a premiere. Thank you so much, Richard, for the swingometer, and I can't wait to see how that looks after 13, the full 13 winter updates. Right, let's begin where we left off last week with the QBO, the quasi-biennial oscillations. So the QBO is currently in its westerly phase, of course. We explained last week. We did look at winters that are coincide with westerly QBOs, but we have got a bit of easterly QBO at the top of the stratosphere as well. So this is from NASA. This is showing westerly and easterly QBO phases. This, of course, is westerly phase of quasi-biennial oscillation. The blue-green area is like the easterly phase of the QBO, and just here as well. So, of course, we know what's happened this year. We start off with a westerly QBO at the beginning of the year. But it should have transitioned into an easterly QBO. You should have seen this blue-green area. Easterly QBO should have descended down from the stratosphere into the troposphere. The troposphere, of course, being around 30 to 50 HPA. What actually happened is that the westerly QBO never really went away, and the westerly QBO is still currently sitting there in the middle of the troposphere. However, further up in the stratosphere, and this is like the top of the stratosphere just here at 10 HPA, further up we have got our easterly QBO lurking. And over the past few days, really the last couple of weeks, but particularly in the past few days, that easterly QBO has begun to strengthen and also to descend. Look at this. If we zoom in, we can see that the easterly QBO is definitely beginning to trend downwards from the top of the stratosphere and heading down towards, not yet in the troposphere, but heading down towards the troposphere. And so it does look as though this easterly QBO is coming back. The question is going to be how quickly it comes back, where it has much impact on this winter. Because of the failure of the easterly QBO earlier on in the year, because of the fact that we went into an easterly QBO, but then it reversed into westerly QBO, it's very difficult to say what's going to happen, because we are in some ways in uncharted territory with this. So it's possible this will take some weeks, some months for the easterly QBO to descend from the stratosphere to the troposphere. I think the easterly QBO will get going next year, no doubt about that. I'm sure the easterly QBO, the next easterly QBO phase will begin in 2021. If this was like a normal sort of transition from west to an east QBO, you would probably expect the time lag from like the beginning of the descension from the stratosphere to the troposphere to take 3 or 4 months. So it will probably, the final sort of movement of the eastern QBO into the troposphere normally would probably be in the spring from here. But because this is such an abnormal situation, it is possible, and I think maybe probable, that this easterly QBO will descend very, very quickly. And so it is possible that this coming winter will be like a west to east transitioning QBO. We did look at that last week, and interestingly, it actually turned out that the westerly QBOs had a better chance of being colder winters than like a west to east QBO. But we'll see. We'll see how it develops. It's going to be one to keep an eye on, I think, through the next few weeks. It's very difficult to say where this is going, but you can clearly see that the easterly QBO is coming back, can't you? You can clearly see that the easterly QBO is starting to descend from the stratosphere to the troposphere. The question is, how long is that going to take, and will we be in an ECQBO, by the end of this coming winter? Certainly going to start this winter in a Westerly QBO Metroposphere, but how quickly will the ECQBO get going? And also, by the way, of course, as this is descending down through the stratosphere, it is putting a cap on the strength of Westerly QBO as well, and the impacts that this Westerly QBO will have. So the reason we look at the QBOs is that Westerly QBOs tend to be associated with a strengthened zonal flow. EC QBOs tend to be associated with a weakened zonal flow and an increased chance of blocking. So if Westerly QBO is being capped and is not, as impactful as it would normally be, because the East QBO is descending, then we could be in business for some blocking through this winter. Going to be very, very interesting how the QBO works out over the coming weeks and months. Of course, we will be keeping you updated. In December, we'll keep you updated in our regular videos, and in January, GavsWeatherVids Sunday Roundup will be returning. Right, solar activity. This hour solar disk is looking on outside the disk today from solarham.net. We have quite a few sunspot regions. Look at this, quite a few sunspot regions going on. Activity has really picked up a lot over the past week. Nevertheless, though, Solarham is reporting that solar activity is at low levels and is expected to remain at low levels for the next 3 days. But clearly we have a lot of sunspots, or more sunspots than we've had for a very long time. This is being picked up as well by the GavsWeatherVids Solar Activity Tracker, updated by a good friend James Ackrill up to today, the 29th of November. Thank you so much, James, for keeping this updated. Now, you can see from the orange line, which is depicting each individual day's worth of sunspot activity, that we really have ramped up the activity over the past few days. Look how the orange line has sort of taken off from being on the floor, from no sunspots around the middle of November, to where we are right now, which is up here. That is quite a dramatic ramp up in solar activity, in sunspot activity. And yeah, so we've got a very active solar disk at the moment. Obviously, this is lifting up the trend lines. You have the thick green and the thick red lines. They are lifting up as well. Solar flux, which is like the noise being given by the sun's activity, is also lifting up. See that by the light and dark pink lines. So yeah, it's all happening on the sun. The solar activity is definitely now at a much more much quicker pace. I wouldn't necessarily say it's at a strong level, because they're not reporting about Solarham. They're still saying that solar activity is at low levels. But clearly, sunspot numbers are lifting up quite dramatically and significantly so. This is the GavsWeatherVids extended solar activity tracker. This takes us all the way back to 2017. You can see that actually right now activity is at its biggest, got the most sunspots right now that we have had on the solar disk since around the summer of 2017. This spike just here was during August 2017. Haven't reached that high yet, but certainly we are, at a level, at a higher level than we've been at any point since, like, the summer of 2017. We can also see that by our trend lines, which are the thick black and thick red lines just here. Obviously, they are above the trend, where the trend lines have been all the way back to the summer of 2017. So solar activity, sunspot numbers right now are the biggest they have been, the most active they have been for over 3 years, around 3.5 years. So quite dramatic developments now, quite dramatic as we're moving on, and we're a year in to solar cycle number 25. Thank you so much, James, for keeping me GavsWeatherVids Solar Activity Trackers updated through these winter updates. This has been sent through by our good friend Richard Traut. Look at this, it's Capatine, it's the Emperor, it's Darth Sidious. And this is showing spotless days. Do it! This is showing spotless days and the current spotless stretch. So let's have a look at this then. So this is the current year, 2020. So for 2020 so far, we have had, I think, it's quite difficult to make this out actually, but I think we've had 266 days without sunspot activity, which is 62% of the year, I think. Comparable to 2020, or 2019 I should say, which had 281 days without sunspots. That is 77% of the year. So as this year is going on, obviously the sunspot numbers are increasing, and that's why the percentage there of spotless days is coming down. Obviously, the current spotless stretch as well is 0 days, as we had, you know, quite a high number of sunspots just yesterday. Thank you so much to Richard for keeping that updated through this season of winter updates. Of course, you will be seeing all of this data, including GavsWeatherVids Sunny Roundup from the new year. Right, this is how the 2020 Atlantic hurricane season is looking. So we're virtually at the end now of the official hurricane season, although we can get storms outside of the hurricane season, so don't say we can't have tropical storms and hurricanes in December. Has happened before. We even had one in January in the 2005-2006 season. But we're virtually at the end of like the official 2020 hurricane season, and this is how the scores on the doors are shaping up at the end of this official hurricane season. We have had a total of 31 tropical depressions. That is tied with 2005. We have had a total of 30, which is a record high, tropical storms. We've had 13 hurricanes, very large number, and we have had 6 major Category 3 or above hurricanes. That is how the scores on the doors are looking for the 2020 hurricane season. At Wikipedia, they are saying that the 2020 Atlantic hurricane season is the most active hurricane season on record. A total of 31 tropical and subtropical depressions, 39 storms, 30 hurricanes, and 6 major hurricanes have formed throughout this season. For the final time, we're going to look at the Atlantic hurricane season by ACE chart, which our good friend Shryan has been updating. So thank you so much to Shryan Brewing for updating these for us, or updating this for us. So this going all the way back to 1851. ACE is telling us how much energy these storms and hurricanes have been given out. The classification is below normal, near normal, above average, and hyperactive. So if we scroll down, we can see that we have had a hyperactive hurricane season this year. So this is how it looks. As of the 28th of December, our ACE is standing at 179.80 with a total of 30 tropical storms, 13 hurricanes, and 6 major hurricanes. That does bring us out at hyperactive. We have been hyperactive for this hurricane season. Let's have a look and see where we are on the league table of hyperactivity. So the biggest season for ACE was actually 1933. 2005 was very, very closely matched. Of course, not 2005 does beat 1933 for like storm numbers. Very much so, actually. Right, so let's find 2020. There it is. So no change really on where we was last week, because there hasn't been any change in terms of ACE. So no change in terms of where we are on the league table for this season. So we're just there. So we are between like 2003 and 1878 with our ACE number of 179.80. So these 2 years are followed by cold winters, of course. 1878 was followed by a severely cold winter of 1878, 1879. And 1887, 1888 was also a cold winter, particularly so around Christmas and New Year of 1887. 2003 wasn't a particularly cold winter, though. So that's it. We confirmed that this has been a hyperactive hurricane season. Of course, we saw a couple of updates ago what that could mean for our winter prospects. Thank you so much, Shryan, for keeping that updated. And you'll be seeing more of Shryan's work in part 2 of this update. And of course, you'll be seeing a lot more of Shryan brewing and you know, his help on these updates over the coming years. Thank you so much to Shryan. Right, this is how the sea surface temperature anomalies were looking last week. We did last week's 12th winter update. So we've got our 4 areas of interest. We've got the ENSO region just here. We've got the Northern Pacific over there. We've got the Indian Ocean through here. And we've got the North Atlantic Ocean over there. That is how the oceans were looking as of last week's 12th winter 2020 update. This is the latest. This is it then for the 13th and final winter update. So that's how the oceans look as we come to the end of our winter update. So let's deal with the ENSO region first of all. Let's go back, and of course this deep blue area is a signature of La Nina. That's cold and average sea surface temperature anomalies from Peru over towards Indonesia. This is going to be a La Nina winter. The only question is how strong will the La Nina be? That's how La Nina was looking last week. This is the latest. Very little change, actually. I think, you know, there's been very little change. There's been barely any movement in terms of the strength of this La Nina or indeed of its position. So we basically have like a uniform La Nina, although it is a little bit stronger, I think, over in the eastern part of the equatorial Pacific Ocean. And this is like at a weak to borderline moderate level. It has not strengthened, though. That is the main thing. Over the past week, there has not been any further strengthening of this La Nina. If anything, there may have been a slight weakening through this central part of the equatorial Pacific Ocean. But even if it has been a weakening, there certainly has been any strengthening. So a weak to borderline moderate La Nina looks like it's going to take us into the beginning of this winter anyway, and it is becoming very, very late in the day now for this La Nina to reach strong or very strong levels. Something unexpected could happen, I suppose, but to me it looks like this is going to be either a weak or moderate La Nina, and probably quite uniform, but maybe a little bit focused on the eastern part of the equatorial Pacific Ocean. Going northwards into the Northern Pacific, that's how things looked last week in the Northern Pacific, with a particular focus, of course, on this northeastern part of the Pacific Ocean. This is how things look this week. So, again, very little change, probably cooled a little bit over towards the coast of Alaska, Canada, and North America as well. In these deeper waters in the northeastern Pacific, it remains warmer than average through there. I think sea surface temperatures are cooling down in that northeastern part of the Pacific Ocean, but not quickly enough to have all that much impact on this coming winter, I wouldn't have thought. So that's something we are going to have to deal with this winter. You know, something we've seen a lot of over the past few years. It's still there right now. And yeah, so that tends to send the jet stream on a northwest-southeast alignment, of course, across America, which can then bring cold air into northern and eastern America, but blow up the jet stream in the North Atlantic and produce cyclogenesis and low pressures across the Atlantic into northern Europe. And I don't think we're going to see all that much of a cool down, certainly for the early part of this winter. Later on in winter, I suppose it might get colder up there, but certainly for the early part of winter, it does look as though those warmer than average sea surface temperatures continue away from the coast anyway. In the Indian Ocean, that's how things looked last week. This is the area we're focusing on now. That's how things looked in the Indian Ocean last week. This is how it's looking this week. Just generally, perhaps warming up a little bit through the Indian Ocean. There hasn't been all that much change, though. Things have been quite stable, I think, in the Indian Ocean. And we'll have a look at the IOD in a moment. And then in the North Atlantic, lastly, let's have a look at the North Atlantic sea surface temperature anomalies. That's how things were looking last week. This is the latest. So very little change in the Atlantic. So the tropics and also the Caribbean and Gulf of Mexico still quite a bit above average, really, despite all of the hurricanes and storms that we've seen, which should in theory have a cooling effect on the tropical Atlantic. Generally, it still looks quite quite warm there, and going northwards into like the northwestern Atlantic. Yes, it looks quite warm through there. Further northwards still, actually it's a little bit cooler, like to the west of Ireland and going towards the south of Greenland. So we don't have a tripole here. This isn't what we call a tripole. We're going to have a look at sea surface temperature anomalies later on in the video, and we're going to go all the way back to 1985 to see how those sea surface temperature anomalies in the Atlantic compare to past years, and see if we can pick out the closest matches to this year at this point in November. This is the 7-day change in terms of sea surface temperatures. So, ENSO region, generally I think more parts of the ENSO region are warming than cooling at the moment. The Indian Ocean, it has this area just here, but it's warming, although the northern Indian Ocean has cooled a little bit. More typically, the North Pacific is cooling. So most parts of the North Pacific and the Northeast Pacific are cooling, but probably not at a fast enough rate to really cool down those sea surface temperature anomalies. And then in the North Atlantic, this area here has cooled a little bit. Tropics still looking generally quite warm though through there. And further northwards, probably very little change actually over the past week in that northern part of the Atlantic Ocean. Subsurface temperature anomalies underneath the surface of the equatorial Pacific Ocean look like this. So this is the surface of the equatorial Pacific Ocean just here. That's where Peru would be. This is where Indonesia would be. And these are the depths of the Pacific Ocean going all the way down to 300 meters. You can see that warmer than average subsurface temperature anomalies are gathering in the western part of the in the western part of the Pacific Ocean at depth between around 100 and 300 meters. But just here we have got quite considerably colder than average subsurface temperature anomalies between around the surface and around 150 meters. Going down to those dark blue shadings, that takes down to around 6 degrees below average, and that is kind of like focused on the eastern part of the Pacific Ocean. So that possibly gives us the idea that this is likely to be an eastern-based sort of moderate, weak to moderate La Nina, perhaps. Right, where to next? I don't think we want to go there, do we? Where are we going next? Where are we going next? So we want to go there. Sorry about that, everybody. I got ahead of myself. This is from ToggleTidbits.com. So this is showing each individual day's worth of temperature anomalies for the central part of the equatorial Pacific Ocean, the ENSO region. This takes us from early September. So you can see this from Toggle Tidbits. So you see around, so each blue dot represents an each day of temperature anomaly, you see what I mean. So the beginning of September just there, that day was around half a degree below average, generally in that sort of ballpark through most of September. But October saw a strengthening of the La Nina, quite a dramatic one as well. So around the end of October, beginning of November, sea surface temperature anomalies in the central part of the equatorial Pacific Ocean were down to around 1.5 degrees, maybe 1.6 or 1.7 degrees below average. But that looks like that increasingly now looks like that was the peak of the La Nina. It looks like the La Nina peaked early in the season and at around 1.5 to 1.6 or 1.7 degrees below average. Since then, sea surface temperature anomalies have warmed up, so they aren't as cold. They're still around a degree below average, somewhere around 1 to 1.2, 1.3 degrees below average, but not as cold as they were like around the end of October, beginning of November. So it does look as though the La Nina peaked early at the end of October, and yes, so it looks like at the moment we are at a weak to borderline moderate La Nina threshold in the central part of the equatorial Pacific Ocean, and maybe this La Nina is a little bit eastern based. CFSV2 is rapidly backing away from its idea of a strong or a very strong La Nina. So this is a forecast from the CFSV2. Of course, you remember a few weeks ago, this black dash line, which is the ensemble mean, was going down to around here, going down to around 2.5 degrees below average on the temperature scale. that's been pulled back week by week for the last 2 or 3 weeks, and where the black dash line goes to now is just there, which is around 1.5 degrees below average, which that's a moderate La Nina threshold, but it may even pull up a little bit short of that even. It might do. So in the end, the black dash line might end up doing something, looking something a little bit like that. I don't know, but certainly CFS has pulled back a lot on its idea of a super La Nina or a very strong La Nina, and now it is forecasting no more than a moderate La Nina event. Southern Oscillation Index is, of course, sort of supporting the idea of La Nina. We are going to have a La Nina winter. You know, it definitely will be a La Nina winter. The question is, how strong will it be? I think it'll be weak to moderate. The SY is just an index that's reflecting the atmospheric state. It's not driving anything in its own terms. It's just measuring air pressures in the Southern Ocean Pacific Ocean between Darwin and Tahiti. This is from Queensland Government. So these are our daily returns in terms of barometric pressure. That's the column for Tahiti, that's the column for Darwin. These are our daily returns. So yeah, I mean, we're positive with the SY, as you'd expect, given that we are in La Nina. Not very positive, but we're certainly on the positive side. And the SY 30-day average has been solidly positive for several months now. So the red line is just here at the moment, which is somewhere around +8, +9. It tells us that the atmospheric setup is reflective of a La Nina, but probably not a very strong sort of La Nina. But definitely the atmospheric setup is really reflective of La Nina, and is likely to be so for this winter. This will be a La Nina winter. Right, so I think with that, we will pause the video there. We took for half an hour. As I said, it's going to be a long one, this. It's going to be an epic to finish off our winter updates. We're going to return, and we're going to look at sea surface temperature going all the way back to 1985. You get yourself a cup of tea and, some nibbles. And I'm going to see you in around 2 seconds' time. See you soon. Okay, back. If you've enjoyed this winter update so far, then please can you like the video? Let us know in the comments what you think, and make sure you're subscribed to the GavsWeatherVids YouTube channel. It's absolutely fantastic. Thank you so much, everybody, for doing that. Right, let's continue then. Let's continue with the 13th and final winter update, part 1. Excuse me. Right, okay, so we're going to look at Atlantic sea surface temperature anomalies back to 1985. So just a reminder that this is how Atlantic sea surface temperature anomalies are looking as of the 27th of November. I want you to ignore this area as much as possible, like the Pacific, Indian Oceans. Ignore that. We're just focusing on the Atlantic. Please just focus on this area just here, the Northern Atlantic Ocean. That is how the Northern Atlantic Ocean looked, or is looking, as of 27th of November. Let's have a look then. So this is how the Atlantic Ocean, North Atlantic Ocean was looking at this point in 2019. I don't think there's much comparison at all to the current year and 2019 right now. So I think we should move on 2019 quite quickly. What do you think, everybody? Do you think there's much comparison between this year and 2019? I suppose there could be a similarity, actually. Having said that, I suppose there could be. But tropics is quite warm. It's a little bit warm up there. It's a little bit cool just there. So actually, I suppose there could be, 2019 could be quite close. Actually, there's no comparison to 2018, definitely not, so we'll skip on that one very quickly. That's 2017. That's generally tended to be quite a close match to this year. I think now, though, we're broken away a little bit from 2017, actually. I think particularly the Northern Atlantic is cooler this year to this point in 2017. I don't see much comparison to 2016 either. Definitely no comparison to this point in 2015 or 2014. No comparison to either of those 2 years, really. That's 2013. I don't see much comparison to that one either. That's 2012. That's tended to be quite close times through this autumn. So what do you think about that one? So I suppose, yes, we've got warm and average sea surface temperature around there. It's a little bit cooler than there, but tropics are still quite warm. So maybe there's a little bit of a similarity between this year and 2012, but not as much as there was earlier on in the autumn, probably. That's 2011, no comparison to 2011. That's 2010. What do you think about that one? So I think we're a lot cooler, especially in the northern Atlantic, south of Greenland, this year compared to 2010. That's 2009. What do you think about 2009? I don't really see all that much of a comparison to 2009. That's 2008, 2008. Again, I don't really see all that much comparison to 2008. That's 2007. Again, no real comparison to that one. That's 2006. What do you think about that? There might be a little bit of a similarity. Oops, don't want to go there, want to go there. Might be a little bit of a similarity to this year and 2006. But I think really perhaps not. That's 2005. I'm struggling to come up with matching years actually here. That's 2005. Again, probably not all that much of a comparison, really. 2005, that's 2004, no comparison. That one either, that's 2003. That might be a closer one. Let me know in the comments which years you think are closest in terms of Atlantic sea surface temperature anomalies to this year. That's 2002. So, again, not seeing much of a comparison with that one. That's 2001. Again, no real comparison there. 2003, definitely no comparison to this year in 2003. That's 1999. Again, no comparison with that one. That's 1998. Again, don't really see all that much of a match there. 1997. Again, struggling to find a match with that one. No comparison until 1996 or to 1995. So we had got a bit of a tripole starting to get going at this point in 1995. It was starting to get warmer south of Greenland, cooler through here, and then warmer down there. So that's what we call a tripole, and that is what we look for a negative NAO. So just before the cold winter of 1995-1996 started, we was beginning to get a tripole beginning to appear in the Atlantic. That's 1994, no comparison there. And now we're back into like the cold AMO era, and also the era that was affected by Mount Pinatubo. So significantly colder than average there through those years of 93, 92, and 91. As well, back to 1990. Again, no real comparison this year to 1990 or to 1989 or to 1988. The Atlantic much colder in these years, back in the cold AMO. That's what we've got coming in the 2020s probably, but we're not yet in the cold AMO, and so no comparison. Look how cold the Atlantic was at this point in November 1986. Wow, that's what a cold AMO year looks like. And I say that's the kind of thing we've probably got coming up in the next 10 years or so, but not at the moment. So really struggling to find matches there. I think probably 2019 and 2012, maybe 2003 could be the closest. Let me know in the comments which years you think are the closest in terms of Atlantic sea surface temperature anomalies to this year, and of course we'll be discussing it on our live stream at 6 o'clock tonight. Indian Ocean dipole forecast looking like this. So I can't explain, I haven't got time to explain about the IOD. If you want an explanation of the IOD and how it could affect this coming winter, please look at the very first winter update that we released on the first Sunday in September, which I think was the 6th of September. All these models, though, are forecasting the IOD to be neutral to negative in December as we start this winter. So the Bureau of Meteorology, CANSIPS, ECMWF, Meteo France, NASA, UK Met Office, and the ensemble, or the model mean, is all sort of, they're all sort of neutral to negative. NASA is actually strongly negative, but looks like an outlier. Most of them are just here, which is neutral to weakly negative with the IOD in December. January sees a reversal. We go neutral to weakly positive. Shouldn't have any impact on the atmospheric state though in January. February perhaps going a little bit more positive. By the time you get through to March and April, we're sort of neutral to positive in those months, and by then perhaps having impact on the atmosphere. Last winter we had a record-breakingly strong IOD. This winter, I don't, and that was partly responsible, we think, for like polar vortex of doom and the very mild winter we experienced in 2019-20. I don't think the IOD is going to be a particularly big player for this winter, so I don't think we have that to worry about. If we have a mild winter again, we will not be able to blame the IOD for that, I don't think. This is how temperatures are looking at 10 HPA over North Pole. This is from the JMA. We'll look at the stratosphere next then. So the grey line is a trend line for the temperature at 10 HPA over North Pole. The black line is the current temperature at 10 HPA. So right now we're somewhere around minus 75 with a temperature over the North Pole. Of course, it's a cooling time of year. You can see that by the grey line, but we are actually colder than average. If you go a little bit lower down towards the troposphere, have a look at 30 HPA, you can see there we're getting close to minus 80 degrees below average at 30 HPA. Both 10 and 30 HPA colder than average. This would normally coincide with a strengthening of the polar vortex. The GFS forecasting is forecasting that the temperature is going to stay pretty cold in the stratosphere over North Pole at 10 HPA over the next few days. In fact, it may strengthen, it may get a little bit colder, going down to minus 80 to minus 85 perhaps as we go through the course of next week. That's where we've got those blue and purple colours, of course. Into more extended range with the GFS, if the page will flip over, here we go. So, so into more extended range, going into the second week of December again, we keep those cold temperatures going, deep purple colours appearing, indicating that the stratospheric temperature is going to get even colder over the North Pole. But what we are seeing signs of is warming over Siberia, the stratospheric warming over Siberia. So you can see how these yellow, sort of green and yellow colours are beginning to gather over Siberia. That is a modest sort of warming of the stratosphere at 10 HPA over Siberia, and could be a precursor to like a sudden stratospheric warming. We're very early in the winter for that to happen, and up to that point, up to the 14th of December, that is not a sudden stratospheric warming, but it might be the start of a warming beginning to get going over Siberia. It could be. GWF is also picking up on this. This is from the University of Berlin. So helpfully they sort of highlight where the North Pole is. So the North Pole is just there. So this is at 96 hours, which is going to take us to the 1st of December. So we've got these deep blue colours, of course. Those are the cold temperatures at 10 HPA over North Pole for the start of December. They continue over North Pole as we get through to the 7th of December. But what we do see again is that we have got some warming taking place around the edges around here. It's not a sudden stratospheric warming up to that point, but it might be the start of something developing in the stratosphere later on into December. This forecast for the zonal winds, zonal fluxes, if you like. So, dealing with 1 HPA first of all, that's as far as you can go in the stratosphere. So at the moment we have got a strong zonal wind at 1 HPA, generally forecasting strong zonal winds at 1 HPA to continue, although there is a little bit of a weakening taking place there at around sort of days 8, 9 and 10. At 10 and 30 HPA, that's the green and red lines just here, just generally quite strong with the zonal winds at 10 and 30 HPA for the next 10 days as well. This is from weatheriscool.com. So this is showing the strength of the zonal wind. Of course, zonal wind is kind of like the engine that's driving the polar vortex, if you like. So as the temperature gets colder at 10 HPA in the stratosphere, so the zonal wind at 10 HPA in the stratosphere gets stronger. And we see that by the trend line here trending upwards, getting ever stronger as we go through the course of the winter. We're actually stronger than average at the moment with the zonal wind, and the GFS ensembles are generally, that's these green lines just here, generally keeping those zonal winds stronger than average for the next couple of weeks. And maybe by the very end of the GFS, that gets us like to 2 weeks out, heading towards the middle part of December, there may be signs of a little bit of a weakening of the zonal wind by then. But generally, the next sort of week, 10 days, we're going to have very strong zonal winds, and they could continue for the next couple of weeks as well. CFS-V2 looking like that. So generally forecasting a weakening of the zonal winds as we go through December and into January compared to where we are right now. But if we put in the bias correcting and take away CFS-V2, you can see that actually the CFS, if you take out the bias within it, how weaker zonal winds actually happens. But the CFS might actually be forecasting quite strong zonal winds, except this one just here, this CFS member just there, which is going for a reversal of zonal winds sometime in the new year, which could be associated, of course, with a sudden stratospheric warming. ECMWF is looking quite interesting in terms of its forecast for zonal winds going into January. This is how it looked last week in terms of the ensemble plume. So last week we was facing this strengthening of the zonal winds, and then possibly as you go to late December and into January, that period just there, signs of a little bit of a weakening. That's how it looked last week with the ECMWF. This is how it looks this week. So of course now we are at that strengthened sort of situation with the zonal wind at 10 HPA. We're just there. But a weakening of zonal winds is going to occur as we go like through the middle into the second half of December. Not a reversal, but certainly a weakening of zonal winds from where we are right now through the first week of December. But look at all these ensemble members down here that are going for like a reversal of zonal winds at the end of December into January. Definitely more of them this week are sending the zonal winds into reverse in late December and early January compared to last week. That's how it looked last week. That's how it looked this week. Clearly many more ensemble members going for a reversal of zonal winds, and that will be around here, by the way, this zero line just there. So all of these ensemble members are going for a reversal of zonal winds late December into January. That could be the ECMWF starting to pick up on a sudden stratospheric one. That will be one to watch in the coming week, and we will continue to monitor that in our regular video updates. Of course we will. Right, we talked to 45 minutes. I'm going to pause the video there, and when we come back we're going to look at snow cover data, and we'll also have a look at the Arctic and North Atlantic oscillations as well. You're going to stretch your legs. I'll see you soon. Okay, we're back, and we're ready to resume for the final time, the final 13th Winter 2020 update part 1. If you enjoyed this video so far, then please click like on the video. Let us know in the comments what you think. Make sure you subscribe to the channel. Okay, so we're going to carry on, and we're going to look now for the final time at Eurasian and Scandinavian snow cover. So this is how things looked last week in terms of Eurasian snow cover and Scandinavian snow cover too. When we did last week's 12th winter update, that's how it looked. This is the very latest, so quite clearly we have seen significant gains in snow cover across Western Russia. Virtual as Western Russia is now covered with snow, and across Scandinavia, probably lost a little bit across southern parts of Scandinavia again compared to last week. So that's the latest. Let's go through them very quickly for the last time. So we're going to rattle through these. This is how things looked to this point in 2018. So we are ahead of 2018 for Russian snow cover, but behind for Scandinavian snow cover. That's 2019, sorry. This is 2018. We are behind 2018 for Russian and Scandinavian snow cover. We're behind 2017 for Russia and Scandinavian snow cover too. We're behind 2016 for Russian and Scandinavian snow cover. We're behind 2015 for Russian and Scandinavian snow cover. We are ahead of 2014 for Russian and Scandinavian snow cover at this point in November. We are well behind 2013 for Russian and Scandinavian snow cover. We are about evenly matched for Russian snow cover to this point in 2012, but we're behind for Scandinavian snow cover. We're very close to 2011 for Russian snow cover, and probably equally matched for Scandinavian snow cover. Look at 2010 as we're setting up for December to remember. Virtually all of Europe, including much of the UK, was covered in snow at this point in 2010. Obviously, we are way behind for like Russian, Scandinavian, and also European and even British snow cover this year compared to this point in 2010. Wow, what a year that was, December to remember. That's 2008, so we're ahead of 2008 for Russian snow cover, probably quite equally matched Scandinavian snow cover. That's 2009, getting ahead of myself. That's 2008, so probably quite close for Russian snow cover, and also behind both for Scandinavian snow cover. That's 2007, we're behind 2007 for both Russian, European, and Scandinavian snow cover. That's 2006, so we are probably quite closely matched Russian snow cover, we're behind Scandinavian snow cover. That's 2005, we're behind 2005 now for Russian, Scandinavian, and European snow cover. We're behind 2004 as well. We're behind 2003 for Scandinavian snow cover, probably quite closely matched for Russian snow cover. That is 2002, so we're behind 2002 for Scandinavian snow cover, probably a little bit ahead for Russian snow cover. 2001, we are ahead, we're behind 2001 for both Russian, European, and Scandinavian snow cover. 2000, we are probably quite closely matched Russian snow cover, and also Scandinavian snow cover as well. We're behind 1999 quite clearly for Russian and European snow cover, although we may be quite closely matched Scandinavian snow cover, and 1998, which we are well behind as well for both Russian, Scandinavian, and European snow cover. Let's go even further back in time at Rutger Snow Lap. So this is 1997. You have to turn your head, stand on your head, turn your head round. All of this orange area is where we've got snow cover. This is in a weekly period, by the way. So this is like the current week, which is week 48 in 1997. So we are behind 1997 for snow cover. That's 1996. We are behind for Scandinavian snow cover. We're ahead, though, for Russian snow cover, this point in 1996. That's 1995. We're behind 1995 for snow cover across Europe, Russia, and also Scandinavia. That's 1994, which we are behind as well. We're well behind 1993. Look at that. Look how much snow cover there was across Europe in the end of November 1993. Wow. 1992, we're well behind that year as well. 1991, we're well behind 1991 too. That's 1990. I think we're probably a little bit ahead of 1990 though, for Russian and also maybe even the Scandinavian snow cover. We're doing a little bit better than 1990. We're doing worse than 1989 though, quite clearly. We're doing worse than 1988 as well. We're doing worse than 1997. We're also quite closely matched for Russian snow cover to 1986, but probably doing better for Scandinavian snow cover than this point in 1986. We're behind 1985, quite substantially so. That's 1984, so what do you think about that? We're probably a little bit behind the Scandinavian snow cover at this point in 1984, but we're ahead for Russian snow cover, perhaps. We're well behind 1983, no comparison at all. We're well behind that year. We're probably behind 1982 as well. We're behind 1981, particularly for Scandinavian snow cover. We're behind 1980, probably quite closely matched to 1979 for Scandinavian snow cover, maybe a little bit ahead, and probably a little bit ahead for Russian snow cover, actually. We're behind 1978, we're behind 1977, we're behind 1976 as well, and 1975. We're behind 1974. We're behind 1973. Look how most of Europe was covered in snow at this point at the end of November in 1973. We're behind 1972 as well. We're behind 1971. We're behind 1970. We're behind 1969. We're not doing very well for snow cover, really, are we? We're behind 1968, and we're also behind for Russian snow cover 1967, but probably ahead, actually, for Scandinavian snow cover. And that is your final view there with winter updates of this year's Eurasian snow cover map. The last thing we're going to look at is the Arctic and North Atlantic oscillation. I'm going to wrap up the video. So, whatever happens for this winter, we can say that we have got cold signals for the start of the winter. And that could or may be important as we move into winter forecasts, of course. So, the AO is just an index that's reflecting the atmospheric state, but when the Arctic oscillation is positive, we've got low pressure in the Arctic. When the AO is negative, we've got high pressure blocking in the Arctic. The AO has been positive throughout most of November. It's one of the reasons we've had a very mild November. But look at this, the GFS ensembles are forecasting the Arctic oscillation to go negative. So despite everything we said earlier on about the zonal winds and being stronger than average, substantially so, and also temperatures at 10 HPA in the North Pole being much colder than average, despite all of that, actually in the Stratosphere, where I suppose where it matters, where it counts, the signals are increasingly towards blocking in the Arctic, and blocking, of course, is a route to push it cold air out of the mid-latitudes, out of the Arctic and down into the mid-latitudes. Been a very long day. NAO is also on the move. Again, the black line shows that the NAO has been positive through most of November, but the GFS ensembles are taking the NAO to neutral or even negative territory into December. This is a signal for blocking, and we are seeing the chance of snow from early December. This is the latest at the 12Z for Saturday, the 28th of November. 12Z ECM run from Tometeo.com precipitation type forecast. Look at this. We see as we go through next week into the opening days of December, rain and snow being forecast here through the Midlands, through Wales, through Northern England, and up to Scotland through the second half next week. That's the kind of thing you tend to find happening when you have a negative AO and NAO. Things start to get very interesting. The jet moves south, we go onto the cold side of the jet, and we can start getting snow and colder temperatures developing then. So despite the stratospheric stuff all supporting like a zonal situation, there could be a decoupling of the stratosphere and the troposphere going on into December, which might allow things to get colder. And certainly from the beginning of this winter, not necessarily saying it's going to last all winter, but certainly from the beginning of winter 2021, we could be seeing cold signals here. Just to say, but for part 2 of this 13th winter update, we're going to be looking at November. So this is how the pattern, 500 millibar height anomaly pattern, geopotential height pattern is looking for November. Been an anti-cyclonic month and mild with high pressure sitting across much of northern and western Europe as well. We have had a lot of low pressure in the Arctic. That's why the AO and the NAO has been positive. Jet stream's been in that sort of position. So it's been a very mild November, despite the fact it's ended on a little bit of a cold note. But it has been a very mild November, and it's also been a pretty dry November as well. Tomorrow we're going to be looking at winters but follow dry Novembers, and also mild Novembers, and we'll be looking at some autumn data as well. It's going to be epic. Part 2 of the 13th winter 2021 update will be epic. Right, finally, if you enjoyed this video, please can you click like, make sure you subscribe to the channel, don't forget to tell your friends about GavsWeatherVids, and let us know in the comments what you thought about this video. And that's it. That is part 1 of the 13th winter update done. 55 minutes. So it has been an epic. I knew it would be, but I wanted to push this one as it is our last update. We're going to be back later on with a Christmas update. I think that's update number 12, perhaps, for Christmas. So that will be coming up mid-afternoon. And then after that, of course, we're going to be live streaming from 6 o'clock, where no doubt we will be discussing this winter update. This video will be placed on Winter Updates page with a written summary either tonight or more likely tomorrow morning, and make sure you check out part 2 of this 13th and final winter update at 6 o'clock tomorrow evening. For the video though, for this video, for part 1, that's all for now, and thanks for watching.